Hi, in this video I'm going to teach you how to compute the properties of a typical weld bead using construction treating it as a line. Notice the proposed case, which consists of an I, W, or S-beam shape welded to a plate. It's okay to say that the bead consists of four rectangles of dimensions W, B, and D respectively. So, the inertia of the bead around the x-axis is computed from the sum of the inertia of each of the four rectangles that integrate the bead about the x-axis, which crosses the center of the bead itself. For the first rectangle, its inertia around the x-axis is expressed as follows, where the square term d over 2 indicates how far the centroid of rectangle 1 is from the x-axis that crosses the centroid of the whole bead. And then, for the second rectangle, its inertia around the x-axis is expressed as follows. Both of these computations are based on the Steiner's theorem if you're guessing where these two come from. Now, maybe you're wondering, why is the height of the second bit equal to d when in the scheme looks like it's not? Well, actually this is an assumption made purposely. In this kind of computations, you need to approximate the dimensions to the ones that actually describes the welded element, in this case the beam, where the significant dimensions are precisely b and d because they are the largest. So, for instance, not even the thickness of the flange is considered. Now, after the explanation, you can notice that because of the symmetry of the case, the inertia of the fourth rectangle is the same as the inertia computed for the first rectangle, and also the inertia of the third rectangle is the same as for the second one. So the inertia of the whole bead around the x-axis is expressed as follows. Up to here, we computed the properties of the bead as its geometry demands. But in order to get its properties treating it as a line, in first place we define IU prime, where the product of this term and the length W of the bead is equal to the properties of the whole area of the bead. Then, solving for IU prime, we got the expression that follows, where if we take the limit of the length of the bead to become 0, we finally get the expression for IU, the inertia of the bead, treating it as a line, which means the length of the bead tends to be 0, as shown in the figures compared below. Notice that once you know the stresses on the beam, this expression gets you one step closer to the design of the leg of weld bead by analyzing the resultant stress. Subscribe to stay tuned. In following videos, I'll show you how to compute this. Thanks for watching.